name's Sean Cullen. I'm a research fellow at Queen's University Belfast, and today presenting a paper that has emerged out of a larger research project that we've been working on. This project, called the Movable Nexus, looks at food in the urban matrix and its impact on the food, water, and energy nexus when we look at design-led solutions for cities that consider the long-term environmental impacts in a very specific context. One of the most challenging aspects to this research is how we measure the impact of food in the city in a way that is useful for architecture and urban design to engage with solutions. And so this paper sets out a method that we've developed that spatializes food data in order to assess the impact of a design intervention in the neighborhood. And we use the city of Belfast as a case study in this paper because it's a project where we have a living lab, or it's a city where we have a living lab. Food is an important metric within the urban context. When London first undertook its ecological footprinting in the early 2000s, it realized that 40% of its ecological footprint came from food, for which it had no policy to address. And that's despite food having a significant role in shaping the built spaces of the city, the large public spaces for supply, and the major pieces of infrastructure for logistics and the supply of food to urban centers. And increasingly, food is a global system produced in distant and distributed landscapes, where major infrastructure and major retailers are the interface through which a lot of consumers engage with food. And the metrics by which food are measured in the city are typically calories, tons, the economic value, or the specific contents of a food, which aren't always very useful to urban designers. And so we looked at the average consumption of a typical resident in Northern Ireland and thought about how we could begin to spatialize this information that might actually be useful for urban designers and architects, and a process and method that might actually be useful to other places and contexts. We've termed this the food print, and we've spatialized the impact of food in the city in two ways. So firstly, the land use required to produce a kilo or a litre of a specific food type, and secondly, the area of forest required to offset the full carbon life cycle emissions for an average resident each year. And this gave us some pretty interesting results. Even though these foods come from across the world, they're part of a larger ecological impact that our consumption in these cities has. And of course, the cultural and social attitudes of those contexts inform diets, which inform, in turn, the ecological footprint. And they're significant in scale to the city and the biocapacity of the city in which the consumption takes place. So we compared this in Belfast to the scale of the individual, to the scale of the household, to the scale of the street. And we were really interested at this point in how we might begin to utilize this spatialization method as a form of assessing a design intervention, and whether that design intervention is having a positive environmental effect or not. And to do this, we took a small design proposition in a neighborhood in Belfast to see how that would impact the food print. We took this piece of infrastructure, which is a major peace wall in the city, and peace walls are common pieces of infrastructure in Belfast that are used as divisive elements to keep communities apart, specifically in areas of violence. And we proposed an aquaponic growing system on this south-facing peace wall. It has approximately a footprint of 45 meters squared, a yield of about 30 crops per meter squared, and can produce a total output of 32,500 kilograms of tomatoes. So we focused on one food to see how this would affect an individual's food print. And when we look specifically at tomato consumption within the neighborhood, the land use was reduced by a total of 90% with this new technical food growing system compared to traditional forms of production. And it reduced the area of forest for sequestering carbon of the full life cycle emissions by about 21%. And this was technically through the removal of major transportation and packaging emissions. And two key assumptions were made within this calculation. The first is that the emissions from the farm were assumed to be the same. So the technical vertical food system used a similar amount of energy output per kilogram of food as a traditional farm. And secondly, that land use change remained the same. And this was in the hope that the embodied energy in the construction of the new technical food system might be balanced out through that component of traditional food consumption. But what we found out when we put this within the context of the holistic footprint of the individual was that it had a very modest change in the ecological footprint. So while it's based on an annual use, you can imagine over a number of years it makes up a bigger proportion. The overall impact really only reduces the individual's footprint by about 0.0051%. Therefore, we found that urban agriculture is effective rather than efficient. It doesn't provide efficiencies to food, energy, water resources in the city because of the scale of the intervention, but it must offer new social, economic, and environmental opportunities to residents. In this case, it's healthy and fresh vegetables on their doorstep while providing them knowledge and employment in a technical food system. Similarly, it allows residents and consumers to be aware of food provenance. And it is these elements that urban agriculture must seek to leverage in order to have a place in the post-carbon city. It offers a unique and resilient form of food supply that doesn't rely on complex global supply chains that are transnational. And it also allows the city to engage in new forms of economic activity, particularly with food and engaging with the experience economy. So rather than food being seen as a good or a service within the city, new forms of experiences around production might be leveraged and unlocked. We don't see this process and this method as a decision support tool. Instead, we see it as in what we previously termed the flexible scaffold, one which empowers designers to engage with effective forms of intervention that remove didactic, data-heavy driven tools from engineering and few management to ones where the wider social, economic, and cultural synergies can make new sustainable forms of inhabiting the city. And as the city is a complex organism, it requires heuristic and reflective forms of design practice that can capture and understand the benefits to interventions that go beyond the drive for few food, energy, water, efficient resource management systems. So thank you.